Hello everyone. In this video we are going to solve question number 49 of GATE 2020 physics paper. The question is that given some function x which is defined like this, for x less than minus 1 by 2n and x greater than 1 by 2n, the function is 0 and the value of function is a constant n between these two limits. So we can just draw these functions. So it's easier to visualize. So we have two limits, minus 1 by 2n and 1 by 2n. Between these two limits, the function has constant value n, and beyond these limits, function value is nothing but 0. Now in the question they have asked us to evaluate this limit n tending to infinity, integral minus infinity to infinity fn x sine of x dx. So in order to solve this question, we have to use this concept that what will happen to this function when the limit n tends to infinity. So if we can just visualize this question by increasing the value of n. So as we go on increasing the value of n, the value of 1 by 2n will go on decreasing, and for n tending to infinity, this will become very close to 0, and similarly the value of n will become infinite. So for limit n tending to infinity, the function will take the form of direct delta function centered at 0, centered at origin, for limit n tending to infinity. Okay, therefore we can just write for limit n tending to infinity, fn of x is nothing but delta of x, which is nothing, the delta function centered at 0. Okay, since the area covered by this function must be finite, therefore this is one of the property of the delta function. Now we can just easily now put this back into equation A, and now we have to evaluate nothing but integral minus infinity to plus infinity. Limit n tending to infinity fn x is nothing but delta x sine x dx. Now one of the property of the direct delta function is, suppose we have some function delta of x minus a f of x dx, some limits x1 and x2. Now this is nothing but f of a given a lies between these two limits. So we can use this property in equation 2. Since our delta function is centered at 0, therefore this a value is 0, therefore this function is nothing but sine of 0, which is 0. Therefore the answer for this question is nothing but 0. And there is another approach through which you can solve this question. Since from this figure you can see this function fn x is symmetric about origin, or it is an even function. So fn x is an even function, and sine x we know is odd function, because sine x, this is how sine x looks like. Sine x is antisymmetric about origin, or it is an odd function. Therefore the product is odd, and hence the integral from minus infinity to plus infinity of this function will just vanish. So there is two approaches through which you can solve this question. The answer is 0. Thanks for watching this video.